Hi there. So in this video we're going to look at solving equations involving fractions. You've probably come across solving equations that maybe don't have fractions, but we're going to have a look at what to do when these appear. I would like just to go quickly over a couple of prerequisite things that I would hope that you would already be able to do. That is solve equations that look like this. So you can watch this, you don't have to, or if you want to have a go at it, pause the video, just make sure you can do these things yourself and then check that you agree with me. So we're solving 4x plus 1 equals 9. We're basically saying there's some value for x, and if you multiply it by 4 and then add 1, we get the answer 9. So to undo that equation, or to get back to the value of x, we need to balance the equation and undo the operations that have been applied. So from 9, the first thing that we would do is undo the plus 1, which is why we're going to subtract 1 from both sides. We don't divide both sides by 4 because the last operation that was carried out on the left hand side was add 1. So that's why we undo the add 1 first of all, and then we can refresh the equation. If we're taking away 1 from both sides, we've basically got 4x on the left, and we've got 9 subtract 1 is 8. So we've got 4 lots of x is 8, which means to undo the multiplied by 4, we're going to divide by 4. So we can either write a wee divide by 4, or we could put a divide by 4 line like that. And we're then left with, they cancel out, times 4 might divide by 4. So we've got x on the left equals 8 divided by 4 is 2. And we know that to be true because we went back to the original equation, which I've kind of scored out a little bit. 4x plus 1 equals 9. 4 lots of 2 is 8. Add 1 gives you 9. So our value of 2 makes that equation true, which is what the whole point of solving an equation is. Let's have a look at the second one. As the x variable is on both sides of the equation. We'll talk a bit about this in a moment, but when you see that the larger quantity of x is on the right hand side, it would be absolutely fine to rewrite it as 5x minus 9 equals 3x plus 1. That would involve less negatives. I'm just going to solve it like this, just in case you get to a situation where you forget to do that. But if you can spot the fact that the larger x term is on the right hand side, if you just swap the two sides out, it will make your arithmetic a little bit easier. But say we don't spot that. What we would normally do is we've got 3x on the left plus 1 equals 5x minus 9. So we're going to go ahead and subtract 1 from both sides. Keep it in green, I think. Where's my green? Here we go. So we're going to take away 1 from both sides, subtract 1. What does that leave us with? It leaves us with 3x on the left hand side, and it leaves us with 5x minus 10 on this side here. What does that then? We've got x terms on both sides, so I need to get rid of the x on the right hand side. So I need to subtract 5x from the right hand side, and that will basically cancel out those. So I've got to subtract 5x on the left. And this is why we're dealing with negative values of x. It's not ideal, but it works. 3x subtract 5x is negative 2x. So we can write that down. Equals this 5x and the minus 5x cancel out. So we're just left with, now it's really important to keep the negative there. That's negative 10 on the right hand side. We want to divide through by the multiplier, or the coefficient of the x term, which is negative 2. So we divide the left hand side by negative 2. We divide the right hand side. You see how there's all these negative signs kicking about. And that's okay, but it's not ideal. So we've got x on the left, negative 10 divided by negative 2 is positive 5. And that would have, I could have solved some of that or made it easier if I had actually written out at the beginning 5x minus 9 equals 3x plus 1. So if you can see that, then that's great. You get the same answer. Just check. 3 5s are 15 plus 1 is 16 on the left hand side, and 5 times 5 is 25 minus 9 is indeed 16. So my value is correct. Just quickly going on to the multiplying out brackets. Hopefully you've got 5 lots of 2x minus 1. 5 multiplied by 2x minus 1 can be written out without brackets by simply saying we've got 5 lots of 2x is 10x and 5 lots of -1 is -5. Hopefully you remember doing that. So we're going to need all that as we go on. So let's just go on to our first example. Here we go. So equations involving fractions. Use the same balancing strategy you would use for more basic equations. Here we've got an equation x divided by 3 equals 7. Well, there's only one thing going on there. So we've got a value x, and what it says is that we're told that we divide that value by 3, and we get the answer 7. Sometimes it helps to write it out in kind of function machine style. It means that if we start at 7 and want to work our way back to x, we have to undo the operation which said divide by 3, which of course the kind of inverse operation is multiply by 3. So I'm going to write on both sides a wee reminder. I want to multiply both sides by 3. So the point of doing that is multiply divide by 3 and divide by 3 are opposite or inverse operations, and so they cancel out, and we're left on the left hand side with x. And on the right hand side we've got the calculating 7 multiplied by 3 is 21, and that's us got our answer, x equals 21. And we can check again, because if 21 divided by 3 does indeed give us 7, so the answer does make sense. Moving on to number 2. It looks similar, but it's got this little extra plus 2x divided by 6 plus 2 equals 5. Now think about that in a kind of function machine. We've got some number, and the first thing we're told to do is divide by 6. And then the instruction is add 2. And that gives us 5. So in order to undo this, get from 5 back to x, we want to do the last thing first, which is the add 2. So we subtract 2 from both sides. And then we can update that or refresh it. The 2's cancel out, so we've got x over 6. And on the right hand side, we've got 5 subtract 2, which is 3. Now we're back to an equation like we just had there in example 1. We've got divided by x divided by 6. To undo that, we can multiply both sides by that dividing number, which multiply by 6 on both sides. Oops. It's not a very good 6. They cancel out. So on the left hand side we've got x, and then we've got 3 times 6 is 18. Does that make sense? Well, going back to the original equation, 18 divided by 6 is 3, and 3 plus 2 is 5, so the equation is true for x equals 18. Okay? If you want to stop and practice some stuff there, then do so. I'm just going to keep going on so you can follow me or join in a moment. So example 3, it's starting to get a wee bit more complex. We've got x plus 5 over 4 equals 6. Now it's very similar to the previous example in that there's a fraction there, but there's also an addition going on. But the big difference in this is, let's have a look at the function machine. Because it says x plus 5 all over 4, that basically means that the x plus 5 doesn't have brackets around it, but it basically says you have to do this first, because the division applies to the whole value x plus 5. In other words, we're basically saying of this function that the first thing that happens to the x is 5 gets added to it, and then there's a division by 4 to give us the answer 6. So again, looking back at going back from 6, the first thing we have to deal with is the dividing by 4. So in order to solve this, we don't subtract 5, we don't deal with the plus 5 like we did last time. We have to deal with the divided by 4. Now we do that, of course, by doing the inverse operation, which is multiplied by 4. And we can, because they cancel each other out, on the left hand side we've got x plus 5, and on the right hand side we've got 6 times 4, which is 24. We've got a simple equation then to solve x plus 5 equals 24. So if I subtract 5 from both sides, we end up with x on the left equals 19. Check that works. X plus 5 is 24, divided by 4 is 6. Yep, that equation holds for a value x equals 19. And example 4, what we've got going on here is a wee bit different. We've got an extra coefficient here. So we've actually got 3 operations. Let's see if we can do a wee function machine for it. You can maybe try it, stop the video, see if you can draw a function machine of that equation. Well, what we've got is x, I'll do it up here, and the first thing that we could say is it's multiplied by 2. Because that's closest to it, we'll say that. Okay, then it says divide by 7, so the next thing is divide by 7. And then, after all that, we say subtract 1. And the answer is 2. So if we want to work back from 2, we're going to have to deal with the minus 1 first, which you probably sussed out already, because that's kind of far away from the x term. So we're going to add 1 to both sides. And we've still got 2x over 7. We've got no minus 1 anymore, they cancel out, and we've got 2 plus 1 is 3. Now we've got two things to deal with, and if you look at the function machine, it suggests that we do the divided by 7 as in multiplied by 7 first. Technically, because of the order of operations, the times 2 and the divide by 7 are reversible. So you could divide by 2 first and then multiply by 7. It usually makes more sense to get rid of that fraction first of all. So I'm going to multiply both sides by 7. Write that down. And that leaves me with, they cancel out. I get 2x equals 21. And I've got 2x equals 21, so I know to divide by the coefficient of the x, then divide through by 2. So on the left-hand side, I've just got x. Now on the right-hand side, of course, 21 doesn't divide evenly into 2 parts, so I can leave it as that. That could be my answer, 21 over 2. If you wanted to change that into a mixed number, we could write 10 and a half. Check and see. 2 times 10 and a half is 21. Divided by 7 is 3, so that whole fraction there would be the value 3, and 3 subtract 1 is 2, so the equation holds for our value x equals 21 over 2. Okay, so our equations are getting a wee bit more challenging. If you want to stop there and try a few, then do so. We've got 2 more examples that we're going to work on here. Let's have a look at examples 5 and 6. Okay, what's going on here? Well, we've got, in this term, we've got x terms on both sides. So we've got variables on both sides of the equation. We've got a fraction here with a denominator of 5. So it looks as though the best thing I can do is to multiply both sides by 5, and that will get rid of that divided by 5 thing going on there. And so if I do that, on the left hand side I've got 4x minus 1. On the right hand side though, I've got x minus 1 multiplied by 5. Now be careful, because there's 2 terms in this expression. So for safety's sake, what I would tend to encourage you to do is not to do the multiplication. You might do that straight away in your head and do that means 5x minus 5, but it's quite common for people to just write down 5x and then the minus 1, because they forget that the multiply by 5 applies to everything. So just to be safe, I always encourage people just to rewrite that as a multiplication in that way and just take a moment to gather themselves. Just avoids or prevents maybe more errors than there needs to be. So we've got an equation here with variables on both sides. If you're eagle-eyed, you'll notice that the 5x here is a larger term than the 4x, so we could swap them round. Okay, I'm not going to do that just now. I'm just going to persevere, because you might not notice to do that, and I want just to keep reminding you about using negatives. So what can we do here? Well, we can add 1 to both sides, and in that case here, add 1 to both sides, we get 4x equals 5x, and then negative 5 plus 1 is negative 4. We want to get rid of the 5x on the right hand side, so I'm going to subtract 5x from both sides. And on the left hand side, that leaves me with 4x subtract 5x is negative 1x, or negative x. And here, again, watching the negative 4 here rather than just 4. Okay. I want to finish off here, dividing both sides by negative 1 to get rid of that coefficient, which means that I end up with here with x equals negative 4 divided by negative 1. Remember, it's positive for a negative number divided by negative is positive. And let's check if x equals 4 is a valid solution. If I go back to my original equation, 4 4s are 16 minus 1 is 15. And 15 divided by 5 is 3. So that whole fraction there on the left hand side has the value 3. And 4 subtract 1 on the right hand side is also 3. Both of those work, or that equation holds for x equals 4. And the very last one, this time the denominator of the fraction is actually an expression in x as well. So what do we do here? We just do exactly the same thing. You notice that I'm not writing out function machines for these. They're a bit more complex, and the idea is that once you get the hang of it, you don't need to try and justify it with a function machine. That was just to help explain the ideas. So in these kind of things, it's probably more hassle than it's worth to try and write a function machine. You can, but we're going to use the same principles. The principle being that in order to get rid of this fraction, we want to multiply through by this term x minus 3. So we're going to multiply both sides by x minus 3. So on the left hand side, they're going to cancel out, which means on the left hand side, I've just got 3x plus 5 equals, and on the right hand side I've got 10 multiplied by x minus 3. Now, just as I did last time, I'm just going to write that as a multiplication there, and I'm going to gather myself. I'm going to remember the rules, which are if I multiply everything in the bracket by 10, that's why we did the wee prerequisite at the beginning, just to remind ourselves that everything multiplies through by 10. Okay, so I've got an equation with x terms on both sides. Have a look. The bigger term again is on the right hand side. 10x is bigger than 3x, so this time I am, having done the previous example, I'm going to do what I would normally do, which is I would just say, oh, well, let's just rewrite that. And that'll avoid some negative terms, because that's sometimes where mistakes occur. And that means I'm going to add 30 to both sides in order to tackle this negative 30. So I'm going to put plus 30 on both sides, and that leaves me with 10x on the left. They cancel out, equals, I've got 3x on the right, and positive 5 and positive 30 is positive 35. I want to get rid of the 3x on the right hand side by subtracting that 3x, but I have to of course balance that by subtracting 3x on the left, which leaves me on the left 10x minus 3x is 7x equals 35. You notice no negative signs in sight here, so it's often a little bit simpler to swap the equation around if the bigger x term is on the right hand side. And that leaves me with the answer x equals 5. Let's go back and check that's a valid solution. 3x, 3 5s are 15 plus 5 is 20. Divided by 5, take away 3 is 2. So 20 divided by 2 is 10, and that's what it says it should give me. So again, x equals 5 is a valid, is the only solution in fact for that equation. Okay, so there's a good number of examples involving equations with fractions. I hope that's useful. Go and practice some more, and I hope that you can look back and use these to help you when you get stuck. Okay, thanks for listening.